All right, folks, welcome back to the second video for 7.1 Law of Sines. So we're going to take a look at yet another kind of case for law of sines, okay? So in this case, you're going to see some information that talks about a side, and an angle, or SSA, all right? And if we look at our triangle, we can see where this comes from. We have one side, we have another side, and then we have an angle, and that angle is not between the sides, okay? So that angle is after you do the other two sides, and that order is really important. Okay, so let's see how this problem is a little bit different than some of the ones we've seen already. All right, so I'm going to start the same way. I'm going to set up a law of sines, all right? So I've got sine of a over little a equals sine of 31 over 8 equals sine of c over 13, okay? Now, when I look at this, I realize that I don't have enough angles to just find the third angle, but I should do a check to see, do I have any full pairs, okay? So this one is definitely not a full pair. This one is a full pair, and this one is also not a full pair. Okay, so it seems like we are kind of forced to start to find angle C. All right, that's the only one we have enough information for. And so I'm going to go ahead and set that as my first step. So number one, find angle C. And so I'm going to do that by using sine 31 over 8 equals sine C over 13. All right, so I used my one full pair, and I set it equal to the other pair where I only know one piece of information. And then I'm going to cross multiply like I did before. So sine C equals 13 sine 31. And sorry, there's an 8 in front of that sine C. And then I'm going to go ahead and divide by the 8. So 13 sine 31 over 8. And then I'm going to go ahead and find C. So when I find sine C, and I turn the other side into a decimal, I get 0.837, something, okay? Now, what does this mean? This means that you have the y value of an angle is 0.837, okay? So let's go ahead and draw a unit circle and see what this could be on our unit circle. Okay, so a y value of 837 could be this angle right here. Okay, so we could consider that angle C. However, it could also be this angle on the other side, and we would call like this bigger one could also be angle C. So I have two possibilities, and I'm going to need to explore both possibilities, okay? And let's take a look at what that gives us. So let's say that I wanted to take a look at the first angle, the acute one, all right? So we're going to take a look at this angle C all the way up here. So when I use my calculator to find what angle has a y value of 0.873, the calculator will tell me that an angle of 56.818 degrees has an angle of, or has a y value of 0.837, okay? So we're going to consider this case number 1. Now, next to it, I'm going to explore case number 2. So case number 2. Well, how do we get that pink angle that we said could possibly be down there? Well, it turns out we're going to use our idea of reference angles. So I'm just going to do 180 minus the value I got here, and that should give me the other angle C possibility. So 180 minus 56.818 will give me another possibility for C, which is 123.182 degrees. Okay? So 2 possibilities. Well, let's take a look at case number 1 and see what that gives us. So if angle C is 56.818, then I can go ahead and find angle A. And I know that angle A is just going to be 180 minus the 31 minus 56.818, and that's going to give me a measure for angle A of 92.182 degrees. Okay. Now let me try the same thing for case 2. How do I find angle A in this case? Well, I'm going to do 180 minus 31, but instead of minus 56, I'm going to do minus 123.818. And in that case, I get an angle A of 25.818 degrees. Okay, so it looks like I'm able to find 2 different triangles. All right, well, the last piece of information I need to find is I need to find little a, all right? And that's going to be the same for both cases. We're going to find little a. Okay, so now that we have angle A, I could say that sine of 92.182 over little a equals the complete pair that I had, sine 31 over 8. And if I solve for a here, I will get, all right, let me cross multiply. I get a sine 31 equals 8 sine 92.182. And I could do 8 sine 92.182 divided by sine 31. And I'm going to get little a equals to 15.522. Okay? So that's what happens if I follow the path for the first angle C that I found, or for case number 1. But let's see if we can do the same setup with case number 2 and come out with another number for little a. So I'm going to set up the same way where I'm going to have sine, but it's going to be 25.818 over little a equals sine 31 over 8. Sorry, that's so squeezed. Let me move this over a little bit, give myself some more room. Okay. So now we're going to do the same thing. We're going to cross multiply. So I get a sine 31 equals 8 sine of that 25.818. All right, I'm going to do the same thing. I'm going to divide by sine 31. And this time when I calculate that out, I get 6.765 for my little a. Okay? All right, so let me zoom back out for a moment so you can kind of see the whole picture. All right? So this case, side-side angle, was different from the other ones because we ended up with not one answer, but actually 2. So you're probably sitting here being like, well, how am I supposed to know? When am I going to have one answer? When am I going to have 2? So we're going to finish off this video by taking a look at what we call the ambiguous case, all right? And that will hopefully help explain how you know when you're going to have possibly more than one answer. Okay, so the ambiguous case, all right? The ambiguous case is a pain in the SSA. Flip that around for your own reading pleasure, all right? But it is a pain whenever we're given a side, and the angle is not in between the 2 sides. And let's talk about why. So it turns out in this ambiguous case that we could actually come up with 3 different possibilities, all right? One case is that the triangle is not even going to make a triangle. All right, there's no triangle formed. So we've got this setup here in the diagram where we're given this angle, all right, and we're given one side, and we want to think about this third side. Like what is this going to look like so that I could make a triangle? And so one case is that the side is just too short and there's no triangle. Another case is that side is exactly right and that you could end up with a right triangle. Okay, so like this would be hitting at 90 degrees. The other case is that this third side could actually be here, okay, or it could be here. So if I were to draw that out, I kind of have like one triangle like this or one triangle like this, okay? So in that case, there's actually two possible triangles that are formed. All right, and the last case that we're looking at is that that third side is long enough only to make one triangle happen, okay? So this is a case where I just have that one triangle and I can't make another triangle. So to kind of think about that last example we did, okay, example number 3. Example number 3 is a really good example of when you might have more than one triangle. And how did we know? Let's go back and look at that. Well, when I was trying to find my angle C, and I got to this point right here, okay? I have to really think about what the calculator gives me versus what I know to be true, okay? So I know if I type in arc sine of 0.837 on the calculator, it will only give me one answer. It will only give me this one. But I also know that when I add all three angles in a triangle, I get 180 degrees. So what I need to check here is this pink angle, okay? Can this option give me a second triangle, okay? So that's really the question we're asking ourselves. And I'll tell you when you're gonna know that. If you try and find the third angle and you've already used up your 180 degrees, then there's no second triangle. But in this case, we were able to find two different third angles. So that means that for this particular case, we could have two different possibilities, okay? So this ambiguous case, take a look at that, but when we come back in the third part of the video, we're going to take a look at a couple more examples where we have this pain in the SSA case, all right? And we'll talk about how we know if there's going to be one triangle, two triangles, or no triangles. So I'll see you back there.